This is a fun one. What are the minimum number of people in a room for it to be probable that two people in that room share a birthday? This is a very famous question in probability. You can think about what the answer might be. Just to give some context, look, if there are 366 people in the room, it's guaranteed that two of them must share a birthday because there are only 365 slots for birthdays. Okay, if you count leap years, 367. Similarly, if there are just two people in the room, it's obviously very unlikely that they share a birthday. If you give somebody one birthday out of 365 days, and a new person walks in, there's only a 1 in 365 chance that they share the same birthday. But when a third person enters the room, it's a little more confusing because it's not just whether you match that third person, it's whether the other two match. Okay, so how can we solve this with probability? Well, first thing we need to do is assign birthdays. And we're going to import NumPy. And kind of like with the probability of heads problem where it's convenient to sort of represent it as an integer, same thing here. And so for np.random.randint, we want to go between 0, we'll just ignore leap years, and 366. So basically, what this will do is it'll assign each person a unique birthday. Let's check this from a couple of runs. I guess if we include 0 and 365, maybe we're going to do 1 in 365. I'm going to switch it. You could have 0 and 365 too. So you can see they're just assigning different dates. We're not going to worry about the month and the year. We just want to get the probability. As you can see, and no surprise, usually these are different. Oh, did I just get a repeat of 308? That was fast. I wonder sometimes when things like that happen. Okay, it's kind of fun to see, right? That's one way we can do it. How long until you get a repeat? But of course, we want to sort of do this more systematically. So what we want to do is keep track of these in a list, right? So let's call it the B-Day list. And we start with nothing in it. And basically, we just keep doing this and we add to the list. Well, how many times do we want to do it? Well, as mentioned, if you do like 366, you're guaranteed to like get a match eventually. And the question is, when will we usually get a match? And so this is the birthday, right? We're giving them all numbers. And then we just want to add that to the birthday list. So we're going to append the birthday. Now, we want to know when we have a match. So we've got to do that check each time, right? So basically, if, okay, we just got a new, well, we need to check it up here. Okay, so if B-Day is in the birthday list, aha, we're finished, right? If that's the case, if you have two people and they match, you actually want it in there because that's two people. Okay, or you could subtract one. Either way, we'll go ahead and add it, right? We'll still add it, but importantly, we'll break out of the list. Okay, so when this condition is not met, we can just add it to the list and keep going. Okay, so let's look at this code. We've got an empty birthday list. We're going to just cap it out at 366. We want to make sure we get enough. And hey, here's somebody, and we give them a birthday. Now we do a special check. Hey, is that number already in the list? Well, if it is, like say it's the 50th person or something, then we go ahead and add it, but then we break out of the list. Break out of the loop, I should say. And if not, which is usually going to be the case, right? They're usually not going to have a match, right? Like if you walk into a room with X number of people, probably somebody doesn't share your birthday, then you just get added, a new number gets added to the list. And then when it's all said and done, it's just the length of the list, right? That's the number of people that have entered the room before we get a match. Okay, so let's run this code, see what we get. 34 people. Okay, and so if we look at the list, the idea is the last person should already be in there. I mean, it's hard to like see, but 355 is the last person, and presumably because it didn't keep going, there you have it. That birthday was already in there, which would be a December birthday, right? Okay, so that's kind of fun way to look at it. Well, what if we run it again? What do we get? 33. Okay, so those are pretty close. Now we got 42 much higher, 14 much lower. Okay, so we have an idea of sort of like where it might be, but you know, let's try to get the number right. Let's do it using a simulation. How many times do we need to do this thing? I don't know. Let's just do it 100. So for I in range 100, okay, we're going to, now I've already got I in there. Maybe let's do in. Okay, so for in range 100, we're going to run this code, right? You can highlight on tab it, pressing the tab key. See, it goes over 2 spaces, which is correct in Python for a tab. And what we want to do with each round now is we want to get the length of the list. So we sort of want a new list, right? We're going to reset this each time, but really outside of this, we want to do the number of B days or something, right? So how many birthdays is it to actually set this up, right? We just saw a list. We got 14 recently. I think we had something like 40 before, some numbers in the 30s. And so what we want to do now, got to line it up correctly, right? Is we want to append the number of birthdays, the length of the birthday list, right? We just want the length. And when it's all said and done, right, we're going to do that for each loop. But when it's all said and done, meaning we're outside, okay, now we can simply get the mean of the list, right? And there's some different ways to do that to get the mean of the list. Maybe let's go ahead and run the code first and see what we get. Okay, so we're looking at what are we getting, okay? Okay, so there you can see the ranges that we get. It's kind of surprising, right? 9 people. What are the odds of that? On the higher ends, you get numbers like 52, 7. So what's the mean of this list? Well, let's convert it to a NumPy array to get the mean. Okay, so we've already imported NumPy, right? So np.array num birthdays, and then we can get the mean. Okay, because you can just get it straight from a NumPy array. Let's see what we get here. 24.21. Okay, so this says, and we can even run it again. Let's see if we get something comparable. 25.68, so close. 25.65. We could add another, we could do like 1,000. 24.994. Run it again. I think this is fun, 24. So we're getting like between 24 and 25. And, you know, I encourage you, go online and look, what is the exact solution to the birthday problem? I'm not going to do this one using traditional probability, but I can tell you the secret is sort of you're sort of like looking at the probabilities, like there are things like this. What's the probability that you don't share with somebody in the room is 364 out of 365, right? You probably don't share. Okay, and then 2 birthday slots are taken, and then you keep going and you multiply the probability that the new person doesn't share with either of those 2 is 363 out of 365. Okay, this is the probability that they don't share. So the probability that they do share, you multiply all these together and it would be 1 minus that, and you keep going until you exceed 0.5.